Hi everyone, welcome back to my channel. In last class we have I have explained about rectifier, which rectifies the input signal. That is, it converts the given AC signal into complete DC signal. But we will not get pure DC. Instead of, we will be getting a pulsated DC. So there we have seen two types, half wave rectifier and full wave rectifier. Now we will be seeing about filter. So if you see the rectifier, it will just convert, it has to convert AC into pure DC, but it will convert AC signal into pulsated DC. That means the DC signal is there, but there will be small amount of AC signal also. So in order to get a pure DC, or you can tell in order to eliminate unwanted AC signal, we will be using filter. So AC signal is given to rectifier. When it is given to rectifier, we need a pure DC, but instead we will be getting a pulsated DC. Okay, pulsated DC. That means it has some amount of AC component. Next, you will be giving it into filter. So you will be getting a pure DC signal. Okay. So we will be discussing about filter. So as already said, it will convert pulsated DC into pure DC signal. So pulsated DC means it contains unwanted AC signal, unwanted AC present in DC. So how will you remove this unwanted AC? Is that by using filter. So filter can be constructed by using passive components like capacitor, indicated as C, inductor L, and resistor R. So by using these passive components, filter will be constructed. There will be the 5 types. One is capacitor filter, next is inductor filter, and next is choke or pipe filter, and next is LC filter, and last one is RC filter. Okay, so first let's see about capacitor filter. Capacitor filter. So I'll just explain with the circuit so it will be easier for anyone to understand. This is the capacitor, and just will connect one load resistor from where you will take an output. So the input is pulsated DC and you need pure DC. This is capacitor. So capacitor actually allows AC and blocks DC signal. So I'll explain that how. We know the reactance of the capacitor. Capacitor reactance we know, which is denoted as X 1 by 2 pi Fc. So here for DC signal the frequency is 0. So 1 2 pi into 0 is infinity. So when capacitor reactance is infinity, this capacitor will go into open. Say now for DC signal, the capacitor will act as an open switch. Okay, So what happens is that when a pulsating DC signal is applied, this capacitor will act as an open switch and no signal will pass across the capacitor, and the DC will flow across the resistor and we will get a DC output. So for the DC signal, this capacitor will act as an open circuit, therefore the DC signal will not flow across the capacitor, instead it will flow across the resistor and hence we will get a DC output. So for AC, what happens is that for AC signal you will have a frequency value. So for some value of frequency you will get some value and capacitor will be closed switch. So again this is for DC signal. So Xc equal to 1 by 2 pi Fc. This is for AC signal. You will get some value. Okay. So when there is a value, this capacitor will become closed switch. So what happens is that now when signal is allowed, AC signal, what happens is that it will act as a closed switch. So when signal is given, DC is allowed because it will act as an open circuit. Now for AC, this is short circuited. So whatever the signal is given, it will take the AC signal and to the capacitor, and no signal will pass across the output. So no output. Okay. So when pulsated DC component is given, and for DC this capacitor will act as an open switch and no DC signal will flow across this capacitor and the entire DC will flow across the resistor, so we will be getting an output. What happens when AC signal is passed? When AC signal is passed, this capacitor will act as a closed switch and hence it will conduct current, therefore all the AC signal will flow across the capacitor and no AC signal will flow across the output resistor, so we will not get output. So that's what I already told. This capacitor allows AC signal and blocks the DC. So by blocking the DC, you will get a DC across the resistor because capacitor is connected in parallel with the resistor. So this is how the capacitor filter works. It allows AC signal and blocks DC signal. Okay, so I'll explain with the graph. This is full wave rectified output. This is full wave rectifier's output. Rectified output. Okay, full wave rectifier output. So what happens when you apply into filter? So let's see that. This dotted lines will make us easier to plot the signal. Okay, so let's assume A, B, C, D, E, F, G, H, I. Okay, so I'll draw the circuit here, capacitor, and in parallel you will be connecting a resistor. Okay, so now we will give an input signal. When input signal is given, till 0 to A, the capacitor will start charging. So the capacitor charges. Okay, charging. Here, before we talk about discharging, I'll tell you one thing. This reactance, if it has a greater value, then the capacitor will discharge slowly. If the reactance of the load resistor is low, then the capacitor will discharge faster. say if this has a high value, if load resistance is high, so discharging will be slow. That means even after the next signal has been arrived, it will keep on discharging its previous signal's voltage. So this is charging, so this is discharging, okay, and this is the next signal. So it will discharge even after next signal is arrived. The signal is arrived, but still it is discharging the previous signal. Okay, now this part alone will be charging. Then again it will discharge, charge, discharge, charge, discharge. So here charging and discharging of the capacitor is based on the reactance, that is load resistance. If load resistance is very high, the discharging will be very slow. So even after the next signal has been arrived, this capacitor will be discharging very slowly. So you can tell it like this. Okay, so that's what I have drawn here. Again, giving into a capacitor circuit or a inductance circuit will straighten the signal, will make the current flow straight. So this is the output. So here if you see this this rectified signal is bit straightened by eliminating the unwanted AC signal. By again giving to it many times, you will get a straight DC signal. So that's what is working of capacitor filter. Now let's go into inductor filter. Inductor filter acts the same way as the capacitor filter, but inductor will be connected in series. Okay, so this is input, this is output pure DC, this is rectified input or pulsated DC. Okay, this is inductor. So here also first let's check in for inductance, inductor reactance XL equal to 2 pi FL. Okay, so for DC, for AC. So for DC signal, as already told, the frequency will be 0. So XL equal to 0. When XL is 0, this inductor will act as a short circuit. So when XL is 0, this is inductor. So inductor will act as a short circuit, means it will act as a closed switch. Okay. Okay. So for DC signal, so it will, what happens is that when DC signal is given, it will act as a short circuit. So when it is closed, the DC signal will flow across the inductor and then to the resistor. So you will get a DC output. Here if you see, FL will have some value. So again XL will have some value. So when XL has some value, it will act as an open circuit. So when it acts as an open circuit for AC signal, this is the load resistor. So when AC signal is passed, this is DC. When AC signal is passed, it is acting as an open switch, so no current will flow across the circuit. So no AC. Okay. So inductor, it actually allows DC, blocks AC. Okay, so that's what I have discussed here. So for whatever input is given, input signal is given, it will have both AC and DC. This inductor, it takes DC signal and gives to load output, and it blocks the AC signal, because for AC signal this inductor will act as an open switch, and for DC signal it will act as a closed switch. So that's how it will allow DC signal and blocks the AC signal. So that's all about the inductor, how it works, and the graph is similar to this capacitor filter. So this is the same way you will be considering the reactance of this load resistor as high, so discharging will be slow, so it will take this path. So repeating this multiple times you will get a straight you'll get a straight DC signal or pure DC signal. So in this class I have discussed about what is filter, why filter is used, and what are types of filter. First is capacitor filter, when it will act as a open switch, when it will act as a closed switch. When it acts as an closed switch, it will allow AC, so no signal will get. When it acts as a open switch, you will get entire DC at the output. This is the graph, and this is the inductor filter, again for AC signal, for DC signal. For AC it will act as a open switch, so no output. For DC it will act as a closed switch, so you will get an entire output at the resistor, that is load resistor. So graph is same like a capacitor filter. So that's all for today's class. In next video I will be discussing about this all three, because these two are bit same and these three are bit same. So this I'll be explaining in the next class. Thank you for watching.